Ever since nuclear fission was discovered in 1938 by Otto Hahn and his assistant Fritz Strassmann, it was used in various ways. From 1939, the year when nuclear fission was first explained by Lise Meitner, up until 1945, the end of the Second World War, nuclear fission was mostly used in the development of atomic bombs. In 1946, after the US dropped 2 atomic bombs over Japan, the UN called for a complete elimination of all atomic weapons, and ever since, the main focus of researching regarding nuclear fission has been focused on the energy yielding. Since then, nuclear energy has proved itself as a very powerful and efficient energy source, but also as an unpredictable danger with long-lasting consequences. We will now try to explain to you the pros and cons of nuclear energy and show you what the future might bring. With that, we want to show you how nuclear energy might just be our best bet to stop climate change, at least for the time being. In the 1940s, everybody was convinced that nuclear power would change our way of life. It was a new and a modern way of making energy in huge quantities and in a relatively cheap way. But since then, we have realized that nuclear energy also has its drawback. The most prominent problem is the storage of the nuclear waste. After the nuclear reaction of the fissile material is finished, the produced waste is highly radioactive and is very dangerous. Therefore, the waste has to be carefully handled and well stored. In the past, the waste was stored in a cooling pool inside of the reactors. But as this storage was filled up, alternative storage places had to be found. Nuclear waste is not yet recyclable. The second problem is the issue of nuclear weapons production. Today there are 8 states known to have nuclear weapons: the United States, France, United Kingdom, Russia, China, India, Israel and Pakistan, but only 5 of them signed the Non-Proliferation Treaty. The Non-Proliferation Treaty is an agreement between the countries to stop manufacturing nuclear weapons. The ones which already have nuclear weapons also agree to destroy their own weapons over a given time period. But the countries which didn't sign the treaty do not engage in reducing their potentially harmful nuclear weapons. Therefore, they represent a danger for the rest of the world. The last and maybe most serious problem is the release of radiation after a meltdown of a reactor. Meltdowns cause huge environmental damage and impacts the health of nearby inhabitants for several generations. Since nuclear power was invented, several accidents and disasters have occurred. About 1 nuclear accident per decade has been recorded. The last accident was in Fukushima in 2011. The emergency generator, which provided power to the reactor, were destroyed by a tsunami. The resulting lack of cooling caused an explosion. Radioactive materials were released, and as a consequence, many people and animals were at risk of severe health damage. The mortality rate increased severely in the following years. Because of environmental damage, over 150,000 people had to leave their homes. The cleanup work is expected to last for 30 to 40 years and will cost over 150 billion euros. All these problems have raised public awareness of the danger associated with nuclear power. Today, nuclear power is often seen as a dangerous and expensive way to produce power. While nuclear energy has many issues and dangers, there is a stronger bias against it in the public's eye than one would expect looking at the numbers. The comparison between nuclear and, for instance, fossil fuel power is comparable to car accidents and airplane crashes. The frequency and numbers of yearly victims of car accidents is far outweighed those of airplane crashes, but the latter, due to it being less common, has a much larger social impact and gains more media coverage, leading more people to fear traveling by plane than by car.
As previously said, nuclear energy has a bad reputation due to its destructive history, but it also has many advantages that are worth considering in this day and age. One such advantage is the massive decrease in CO2 emissions it would bring if it were to replace fossil fuels as our main source of power. Nuclear plants decrease CO2 emissions by simply not emitting it, and in our age of climate change, any CO2-free energy source is vital. To give you an idea of the amounts of harm fossil fuels can do, when you burn a single barrel of oil, you release 118 kilograms of carbon into the air. On the other hand, when you use up the same weight of uranium in nuclear fission, you release 0 kilograms of carbon into the air. The next big advantage nuclear energy has is that it is considerably safer than any other energy source, apart from solar and wind energy. It's true that there have been nuclear disasters over the past years, but the worst ones were mostly because natural disasters, not because of an inherent danger of nuclear power plants. Besides, there have been over 100,000 coal mining related deaths since 1900. Also, while oil spills rarely harm humans, in just the BP oil spill, over 82,000 birds, 6,000 turtles and 25,000 marine mammals died due to the oil contamination. And of course, last but not least, it is the emissions of fossil fuel burning that cause many of the environmental problems we face today. The next one is that the nuclear industry has massive potential to improve on its flaws. Research in nuclear fission stopped in the 1980s, but recently there have been a lot of new ideas that could make the nuclear plants far safer and drastically decrease the toxicity and half-life of nuclear waste. After a quick explanation of nuclear fission, we will take a look into the future of nuclear energy. To achieve nuclear fission, we fire neutrons at heavy element nuclei, splitting them into smaller parts. Part of the mass is then turned into energy we can harvest in our reactors, using it to fuel turbines generating electricity. Although nuclear energy could present a way for us to bridge the time until renewable energy can provide the majority of our power, we will take a look at what the industry has in store for us before we can completely depend on renewable energy. Currently, we use third-generation reactors. They are the second generation of commercially viable reactors. The first generation were prototypes. Researchers are now working on the next generation of power plants. The goals of these advanced reactors are improved safety, sustainability, efficiency, and cost. One such advanced reactor is the Allegro, a fast reactor that can recycle certain nuclear wastes as fuels, reducing the overall half-life and radioactivity of those wastes. Another type would be the thorium reactor. It uses thorium to turn wastes into fuel, producing waste of its own with much shorter half-life. Thorium is also 4 times more abundant than uranium, making it a better long-term solution. There is another way to produce nuclear energy, nuclear fusion. It makes the stars shine and maybe one day the lights in our cities. Unlike nuclear fission, which uses heavy elements and breaks them apart, fusion brings atoms together. But to achieve this quantum dating service has to happen in places of massive pressure and extreme temperatures, like the core of stars where electrons are stripped away from their nuclei. Hydrogen nuclei collide at tremendous speeds, overcoming the intermolecular repulsion and fusing together to form helium. This process continues to heavier and heavier elements until it reaches iron. Then, a star can no longer produce enough energy to counteract its own gravity and collapses. The fuel needed for fusion is an isotope of hydrogen, deuterium, abundant enough in our oceans alone to constitute our world with energy for millennia. While we can achieve fusion in massive reactors and magnetic confinements, the energy needed to achieve this fusion is far larger than the energy gained. In other words, we can do it, we're just not good enough at it, which we might never be. It's possible that fusion may never become a viable source of energy. There are, however, projects currently at work like the ETR in France, an attempt at building a reactor powerful enough to produce 10 times more energy than is used. While the ETR itself won't become commercially viable, it provides an opportunity to research fusion on a larger scale. The project is still under construction and won't become operational before 2030. In 2010, the follow-up project Demo was launched. Planned to be the last step before fusion commercialization, it will provide a small power grid with energy, produce its own fusion materials, and hopefully prove that fusion is the energy source of tomorrow, or maybe the 2040s. Now, on to the last and most important advantage of nuclear power over renewable energy, which is that it's efficient enough to compete with fossil fuels. Renewable energy, like solar or wind energy, are not nearly efficient or profitable enough as of now to provide the majority of our energy. While nuclear energy is far from a perfect solution, it is already efficient enough to be our primary energy source until renewable energy sources will be. Scientists have estimated that by 2040, solar, wind and hydro energy will surpass nuclear power and fossil fuels in terms of power output. Yet, CO2 emissions have only been estimated to rise in the future. The best solution right now might be to ditch fossil fuels as soon as possible and let nuclear energy pave the way for renewable energy to take over.